Unit 7, Circles, Lesson 5, Secants, Tangents, and Angle Measures. Your objective for this lesson is to apply properties of secants, tangents, and intercepted arcs to solve problems. Okay, so last lesson we discussed what a tangent line is, and it intersects a circle at exactly one point. A secant is a little bit different because it is a line that intersects a circle in exactly 2 points. You can see here a secant line, and it's intersecting the circle at the stars. This theorem says that if you have two secants or chords that intersect in the interior of a circle, then the measure of the angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So right in this diagram, you can see that angle 1 is labeled for you, angle 1, and its vertical angle is right here. I'm going to put a red dot at its vertical angle. So this is saying angle 1 is equal to the measure of arc PR plus the measure of arc SQ divided by 2. So is its vertical angle, since those are equal. So if I know, for instance, that PR is 40 and SQ is 20, then angle 1 is going to be 40 plus 20, this is degrees, divided by 2. So that's 60 degrees over 2. So angle 1 is 30 degrees. Okay? Here you see if a secant or a chord and a tangent intersect at the point of tangency. So right here we have secant TV and tangent XY. Our point of tangency is point T. So this is T. Then the measure of each angle formed is 1/2 the measure of its intercepted arc. So angle YTV is half of arc TV, and angle XTV is half of arc, TUV. Example 1, we want to find x. Okay, so this is that first property we were talking about. So we have an angle and its vertical angle. We have two secants basically intersecting in the circle, or two chords intersecting in the circle. So x and its vertical angle is half of these two arcs, the intercepted arcs, when you add them together. So x equals 30 plus 55 divided by 2. Okay, so here are the intercepted arcs. Add them up, divide by 2. 30 plus 55 is 85 degrees. When we divide by 2, I get 42.5 degrees. So x is 42.5 degrees. Example 2. I should say find y, not x. Okay. So finding y. Well, I see I have a chord and a tangent intersecting right here. That means that the angle formed, angle y, is half of the measure of the intercepted arc. In other words, y equals half of the intercepted arc, which is 168. Well, 168 times 1/2, or 168 divided by 2, is 84. So y is 84 degrees. Okay. If two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, so before we're talking interior, now we're talking exterior, then the measure of the angle formed is 1/2 the difference between the measures of the intercepted arcs. So you can see here we have two secants intersecting at point P outside the circle. So the angle formed is angle APD, angle P. That is 1/2 of the difference of the two intercepted arcs. So BE is one of the intercepted arcs, AD is the other. You see BE, arc BE minus arc AD times 1/2. Same thing here. We have a tangent and a secant intersecting at point Q. So we say the major arc GKJ minus the minor arc GH times 1/2 divided by 2. And two tangents, same thing. So major arc MTN minus minor arc MN times 1/2. Okay, example 3. We want to find the measure of angle MPN. So MPN, which you can see is formed, the vertex is at the intersection of my two secant lines. So the measure of angle P, or I should say MPN, is 1/2 of my big arc, so arc MN, minus the measure of the small arc, RS. And you can see that arc MN is labeled 34 degrees and RS is labeled 18 degrees. 34 minus 18 is 16. So that means that the measure of my angle, so measure of angle MPN, is 8 degrees. Okay? So just plug into your formula, multiply by that 1/2, and you get 8 degrees. And that wraps up lesson 5.